Hi guys, Mrs. Kohler here. We're going to go over how to solve multi-step equations. First things that you want to think about. Number one, distribute or combine like terms first. So when you distribute, that's when you see parentheses. So when you think of distributive property, parentheses with a number out front here somewhere. All right. Combining like terms, that's like if you have, I don't know, 5y plus 2y equals blah, blah, blah. All right, that 5y plus 2y, you can combine them to make 7y. All right, that would be combining your like terms. Step number two, you want to eliminate the smaller variable. So if you have, let me think, if you have negative 10x on one side, and on the other side of the equal sign, you have 3x. All right, your smaller variable is going to be that negative 10x. So to eliminate that, you have to do the opposite. You're going to want to add 10x to both sides. And when you do that, then these will cancel because they make 0. And then 3x plus 10x would give you 13x on the right side. All right, just a quick example for that. For step 3, once you get to that point, you're just a regular two-step equation. You're going to do your order of operations, or PEMDAS, backwards. All right. So first you're going to look for subtraction or addition. And then when you eliminate that, you're obviously going to do the opposite. If it's addition, you're going to subtract. If it's subtract, you're going to add. Then take care of your multiplication or division after that. All right. Same thing. You're just going to do the opposite. So if we move on to the first example, example 1 has 3x plus 18 equals 2 times 4x minus 6. So right off the bat, we have some distributive property. We have this 2 outside the parentheses, so we're going to multiply it by the 4x, which is going to give us 8x, and then 2 times this negative 6 will give us negative 12. And then on the left side, we still have 3x plus 18. All right. Now, which side has the smaller amount of variables? We have 3x, we have 8x. So the 3x is what we're going to eliminate because it's smaller than the 8x. So when we do that, the 3x's cancel. We just have 18 on the left side. And then the 8x minus 3x will give us 5x. And we still have the minus 12. All right, now we're going to go to our PEMDAS backwards. All right, so we're going to add 12 to both sides because that's the opposite of the subtraction. Those are going to cancel because they together make 0. We have 5x on the right side. We have 18 plus 12, which gives us 30. All right, now that 5x means 5 times x, so we have to divide both sides by 5 because that's the opposite of multiplying. So the 5's cancel out. 30 divided by 5 is 6. So we end up with 6 equals x as our final answer. All right, so this one has one solution. If you get it down to one variable, we're down to 6 equals x. That's a one solution problem. All right, so on the next example, okay, so we have 12x minus 9x equals 3 times 2x minus 1. On the left side, we can combine like terms. So if we have 12x's and we're taking away 9x's, that leaves us with 3x's. All right, on the right side of the equation, we can distribute. 3 times 2x gives us 6x. 3 times negative 1 gives us negative 3. And our equal sign goes in the middle. Now, which x's is the smaller amount of x's? That would be your 3x. It's a positive 3x, so to cancel it out, we have to do the opposite, which is negative 3x or minus 3x on both sides. Now, those 3x's cancel, and we get 0 equals 6x's minus 3x's is 3x's. And then we still have that minus 3 that comes down on the right side there. So, order of operations backwards. The opposite of subtracting 3 is adding 3. So those cancel. We have 3 on the left side, and we just have 3x on the right side. And then to cancel out the 3 that's with the x that are being multiplied, we're going to divide. Cancels on that side, and on the left side, 3 divided by 3 is 1. So we get 1 equals x, which is the same as x equals 1. So again, this is an example that has one solution, 1 equals x, or x equals 1. If we go to the next example, all right, example 3. This one again has some distributive property we got to take care of first. So 4 times x is 4x. 4 times 2 is a positive 8. And then on the right side, we still have 4x minus 5. All right. Now, if you ask yourself which side has the less amount of x's or the smaller amount of x's, you're going to see that they're the same. So what happens when we subtract 4x from both sides? Well, if you do that, it'll cancel on both sides. All right, leaving you with 8 equals negative 5. All right, this is not new math or anything. We know that 8 does not equal negative 5. So the answer to this would be no solution. All right, the last two problems I said each had one solution because they had x equals a number. This one, if your variables cancel out and you just have a number equals a number that is not true, it's kind of like a false statement, then you know that it is no solution. So we know that that's false. 8 does not equal negative 5. All right, so for our last example then, same thing, we're going to do some distributive property. Don't let that fraction out front freak you out or anything. So if you're taking half of something, that's the same as multiplying by half. So half of 6x gives us 3x, and then half of negative 12 gives us negative 6. All right, then on the right side, same thing, we're distributing 3 times x is 3x, and 3 times negative 2 is negative 6. So, kind of like before, both sides have the same amount of variables, so we're going to get rid of them and see what happens. So I'm going to subtract 3x from both sides, and it's going to cancel on the left and cancel on the right. What we're left with is negative 6 equals negative 6. All right? Different from our last example, this is true. All right? If you're left with just two numbers after your variables have canceled, then you have a true statement, then that would be infinitely many solutions. This is how I let you guys abbreviate it. All right? Infinitely many solutions, meaning any value that you plug in for x will still make the equation hold true. All right? Hope this helps you out a little bit. If not, you can always ask me during class or shoot me an email.